Hello everyone, welcome back to Physics online classes for class 11 students. Let us continue chapter 2 units and measurement. In today's class, again we are going to solve examples on to derive an equation between different physical quantities part 2. In the previous class, we solved some examples based on second application. Today also, again I am going to solve some more examples related to that second application, that is relation between different physical quantities. So the second application is very important. Each problem carries 5 marks in your annual examination. Let us start the class. See here, in the previous class we solved 5 examples. In that, third and fifth example I had given as a homework. I hope you all solved those two given assignment problems. Now I am going to solve sixth numerical problem. See here, to derive the relation lambda equal to h divided by m into v. What is the equation? Lambda is equal to h divided by m into v, using dimensional analysis, where lambda indicates de Broglie wavelength, h indicates Planck's constant, m indicates mass, and v indicates speed. What is the equation? Lambda equal to h divided by mv. That means the de Broglie's wavelength depends on Planck's constant, mass of the particle, and speed of the particle. Derive the required relation for de Broglie wavelength on the basis of dimensional analysis. So de Broglie's wavelength in detail you are going to study in PUC second year. Dual nature of light, there is a chapter. So there in detail you are going to study about de Broglie's wavelength. Now let us derive the required relation lambda equal to h divided by mv. Yes, first step we have to write the given equation. You already solved examples in the previous class. You can remember and try to solve yourself. Don't sit quiet. Take a rough paper, write down the question and try to solve yourself. Given equation is lambda equal to h divided by mv. This is the given equation. What is the first step? You have to write in the form of proportionality. Lambda is proportional to h raised to a, m raised to b, v raised to c. Or we can write lambda equal to k. This is proportionality constant or dimensionless constant k. Remaining is h raised to a, m raised to b, v raised to c. Let us take it as equation number 1. Then what is the second step? Writing the dimensional formula of equation 1. Writing dimensional formula. Writing dimensional formula of equation 1. Yes, how to write the dimensional formula of equation 1? You can observe. On LHS side, we wrote lambda. Lambda is wavelength. Wavelength. Wavelength is equivalent to length. So, we can write simply L is equal to K is dimensionless. Constant, leave it. Come to the next term, H. H indicates Planck's constant. We already derived Planck's constant. Planck's constant is given by the dimensional formula m L square divided by T raised to A. See here, Planck's constant, we have the equation E equal to hf, h equal to E divided by F. Energy divided by frequency is 1 by T. You can remember this relation. So directly I can write Planck's constant is m L square by T raised to A. Then second term is m raised to b. I can write capital M raised to b. Then third term is velocity or speed, that is L by T raised to c. Now we can write the equation as, here on LHS side I can write m raised to 0, L raised to 1, T raised to 0 is equal to, here we can write m raised to a, L raised to 2a, t raised to minus a. Then m raised to b, l raised to c, t raised to minus c. Then we can write here m raised to 0, l raised to 1, t raised to 0 is equal to, here m and m bases are same, power must be added, m raised to I can write a plus b. Then here also L, here also L. So L is base, bases are same. Power must be added, powers are 2a plus c. Then T and T, bases are same, power must be added. So we can write it e raised to minus a, plus into minus will be minus c. So this is equation number 2. Right? Then next step, equating the dimensions. Equating the dimensions of m, l and t. Equating the dimensions of m, l and t on both sides of equation 2. On both sides of equation 2. Yes, m raised to 0, leave it. Remaining is what? M raised to a plus b. I can write a plus b equal to 0. Then second term, L raised to 2a plus c equal to L raised to 1. Then third term, t raised to minus a minus c equal to 0. Now from these three equations, let us find the value of a, b, c. See here, I am going to find here. First I can write, we got a plus b equal to 0. Second one, 2a plus c equal to 1. Third one, minus a minus c equal to 0. You can observe here. These three terms again I wrote here. Now a plus b equal to 0. Here we can write a equal to minus b. Here minus a minus c equal to 0, or we can write here a equal to minus b. So this equation can be written as minus a equal to c or a equal to minus c. Now I am going to take this equation. What is the equation? 2a plus c equal to 1. So this equation can be written as 2 into. In place of a, I can write minus c plus c equal to 1. 2 into minus c will be minus 2c plus c equal to 1. Minus 2c plus 1c will be minus c equal to 1. Therefore, c equal to minus 1. So, c equal to minus 1 we can substitute in this equation. Therefore, a equal to minus c, a equal to minus, c value is minus 1, minus into minus will be plus. So, we got a equal to 1. Similarly, a equal to minus b, b equal to minus a, b equal to minus, a value is 1, substitute here, we got b value. So, we got a equal to 1, b equal to minus 1, c equal to minus 1. So, substitute all these values in equation number 1. Substituting a, b, c in equation 1. What is equation number 1? Equation 1 is lambda equal to k into h raised to a, m raised to b, v raised to c. Substitute here, k keep as it is, h raised to a value is 1, m raised to b, that is minus 1, v raised to c, minus 1. K, h raised to 1, m raised to minus 1, v raised to minus 1. Or we can write lambda equal to k, keep as it is, h divided by mv. M raised to minus 1, v raised to minus 1, we can take directly to the denominator. So this is the final equation where what is the value of k experimentally? K equal to 1. Therefore, lambda equal to h divided by mv. This is the required relation. Is it clear? Then, come to the 7th example. To derive the relation t equal to 2 pi square root of L by G using dimensional analysis. So this question is very important. Many times the students got this equation in their midterm examination as well as in annual examination. Very, very important example. Similar steps you can follow here also. So here T indicates the time period of oscillation of simple pendulum. L is length of the pendulum. G is acceleration due to gravity, or time period of oscillation of simple pendulum depends on its length and acceleration due to gravity. Derive the required relation for the time period on the basis of dimensional analysis. Yes, try to solve yourself this problem. This is very important. First we have to write the given equation. T equal to 2 pi root of L divided by G, where T indicates a time period of oscillation of simple pendulum. What is the first step? We have to write this equation as T is directly proportional to 2 pi. Remember, 2 pi is dimensionless constant. So don't use 2 pi, leave it. So remaining is what? L raised to A, G raised to B. Or we can write proportionality constant K. This is dimensional constant K. L raised to A, G raised to B. Keep as it is, equation number 1. Right. Then second point, we have to write its dimensional formula. So writing dimensional formula of equation 1. Yes, T is time period, time interval. So we can write simply T dimensional formula. T raised to 1 is equal to, K is dimensionless, leave it, L into G. L means what? Length. L raised to A. Then G is acceleration due to gravity, L by T square raised to B. Or we can write here m raised to 0, L raised to 0, T raised to 1. This is on LHS side. Here we can write L raised to A. Here it is L raised to B, T raised to minus 2B. Or we can write m raised to 0, L raised to 0, T raised to 1. Keep as it is. On RHS side, bases are same, power must be added. So we can write L raised to A plus B, T raised to minus 2B. Let us take it as equation number 2. Here we can write m is 0. Right? Now, what is the third step? Comparing, equating dimensions in equation number 2. So equating the values, m is 0, leave it. So L raised to 0, L raised to A plus B. Therefore I can write A plus B equal to 0. Then time is here T raised to 1. On RHS side T raised to minus 2B. So I can write minus 2B equal to 1. So from these two values, we can find the value of A and B. See here, minus 2B equal to 1 can be written as 2B equal to minus 1, B equal to minus 1 by 2. This is the value of B. Then A plus B equal to 0. Substitute the value of B here. A, in place of B I can write minus 1 by 2 equal to 0. Or we can write A equal to minus 1 by 2. When it is taken to RHS side, it becomes plus 1 by 2. A equal to 1 by 2. B equal to minus 1 by 2. A equal to 1 by 2. Substitute these two values in equation number 1. So therefore, equation 1 becomes, what is equation number 1? T equal to K into L raised to A. A value is 1 by 2. G raised to B. B value is minus 1 by 2. Or we can write K into root of L divided by G, because G raised to minus 1 by 2 we can take to denominator. So therefore, here the value of K, experimentally it is found to be K equal to 2 pi. Experimentally here we can consider, because in the given equation we have 2 pi root of L by G. So therefore K equal to 2 pi. Substitute here, we will get T equal to 2 pi root of L by g. Experimentally, the value of k is found to be 2 pi. Hence, the required relation is t equal to 2 pi root of L divided by g. Is it clear? I will solve one more problem. Here, to derive the relation f equal to 1 by 2L into root of t by m on the basis of dimensional analysis, where f indicates the frequency of oscillation of the string, L is length of the string, T indicates tension in the string, m is the linear density of the string, or the frequency of oscillation of a string depends on length, tension and linear density. Derive the required relation for frequency on the basis of dimensional analysis. So first we have to write the given equation f equal to 1 divided by 2L into root of t divided by m. Now I am going to write its proportionality equation as, first we have to write f is directly proportional to 1 divided by 2L. Here 1 by 2 is dimensionless constant, leave it. Remaining is what? Only L raised to A, T raised to B, M raised to C. 1 by 2 is dimensionless constant, leave it. So now we got f is equal to dimensionless constant k, L raised to A, T raised to B, M raised to C. Let us take it as equation number 1. Now we have to write their dimensional formula. So therefore, dimensional formula of equation 1. F indicates frequency. Frequency is what? 1 by T. F equal to 1 by T is equal to K. This is dimensionless constant. Leave it. L raised to A. L indicates length. So capital L raised to A. Then T indicates tension in the string. Tension is equivalent to force. Remember, what is the dimensional formula for force? M raised to 1, L raised to 1, T raised to minus 2 raised to B. Then third term is M. M is not mass here. Read the problem. M indicates linear density. Linear density is equal to mass per unit length. Right? See here, I can write mass per unit length m by L raised to C. Now we can write 1 by T can be written as m raised to 0, L raised to 0, T raised to minus 1. This is frequency. Dimensional formula is equal to L raised to A. Here m raised to B, L raised to B, T raised to minus 2B. Then last term m raised to C, L raised to minus C. Now this equation can be written as m raised to 0, L raised to 0, T raised to minus 1 is equal to, here bases are same, L, L and L. I can write L raised to, bases are same, power must be added, so I can write L raised to A plus B minus C into m raised to, here m raised to B, m raised to C, powers are added, m raised to B plus C. Then last one time T raised to, I can write minus 2B. This is the dimensional formula of equation 1. Let us take it as equation number 2. Now equating equation 2, we got the value of A, B, C. Equating dimensions on both sides of equation 2, therefore we can get m raised to B plus C. So B plus C equal to 0. Then L raised to A plus B minus C. A plus B minus C equal to 0. Then third one, minus 2B equal to minus 1. Therefore 2B equal to 1. B equal to 1 by 2. We got the value of B here. B equal to 1 by 2. Substitute B value here. B plus C equal to 0, 1 by 2 plus C equal to 0, C equal to minus 1 by 2. We got B and C value. Now substitute here A plus B minus C equal to 0. A plus B. B value is how much? 1 by 2 minus 1 by 2 here. Minus of minus will be plus 1 by 2 equal to 0. So we will get the answer A plus 1 by 2 plus 1 by 2. So we will get A plus half will be how much? 1 equal to 0. So therefore A equal to minus 1. So these are the value of A, B and C. So these values we have to substitute in equation number 1. So what is the equation number 1? F equal to K into L raised to A, T raised to B, M raised to C. What are the value of A, B, C? A equal to minus 1, B equal to 1 by 2, C equal to minus 1 by 2. Substitute in equation number 1. So therefore we can write F equal to K, keep as it is. L raised to A value is minus 1. T raised to B value is 1 by 2. M raised to minus 1 by 2. So I can write F equal to K, keep as it is, 1 by L root of T divided by M. Experimentally it is found that the value of K is how much? The value of K is equal to 1 by 2. Therefore, the final equation we can get 1 by 2L into root of T divided by M. So, this is the required equation. So, totally we solved 6 examples in the second application. Remember, I had given 2 examples as an assignment. Try to solve yourself to get the required equation. So, in the next class, we can solve the examples based on third application of dimensional analysis. Thank you.